we can, well, here it is. This is what I've done with it over the years in order to teach myself forth, color forth, assembler, in order to rehearse code, in order to determine all kinds of the judgments that Chuck made, and to speculate as to why he did certain things. Obviously, I don't know why he did things he did. No one knows for sure why Chuck chose the swap he chose to use rather than exchange, but I have a sneaking suspicion it has to do with swapping an address into the EDX register. And in situations where that happens, I assume that's efficient as compared to more efficient two-op exchange or a two-register exchange rather than a three-register swap. But no one knows unless Chuck discusses that. But we can play with those ideas and we can find out, how those kinds of things work. So also I can use this as a calculator, like I said before. In this particular version of the program, here is the sum diff prod quo and a whole lot of addressing working with the registers. And so my new setup now does you do a get and then you type sum and it shows sum or get diff or get prod or get quo, and it shows a remainder with an R on the next line. Now if I did get and I did drop and dupe, and if I did quo, you notice the remainder is gone. If there's no remainder, I don't print the remainder. Okay, and so it loads the previous block, my see more math block. It which also loads macros. We talked about that earlier. Now here's a trick. This is the trick. This is a trick. All right. This word is defined by this actual block number. Okay, and you add the number 49 to that, and what you end up with is the address of the word sum right here. Okay, and so we add that to an offset, and the offset is actually in the word sum. When an offset is fetched, we fetch that address, and then we detag the word. Remember we talked about, I added some detag words. Here's a definition for it right here, and all it does is it ships out the tag and then shifts the word back into position. These words are detag number, detag word, tag space word, to shift it back in to make space for a tag, and then also tag space number. And then we can get tag with a flag if we need to. I use those words with something I put on 78, yeah. I didn't have room for it much other places. Here it is. Here's detag. And detag duplicates the number I want to detag, gets the tag, and then jumps to the appropriate detag depth the same as the tagging system in the editor itself. There's no tag on extensions. The first tag is for yellow word. Yellow word? One yellow word? Yeah, I think so. Well, we can look that up. 2 is the yellow number. 3 is a red word. 4 is a compiled word. 5 is a number. 6 is a number. So, there they are. There's 7 is another word, a yellow word. Well, 7? No, 7. 7 is the cyan word, and 8 is the yellow number. 9 is the what is 9, 10, and 11. That's 9. A and B are text. That's the lowercase, capital, and all caps, and then the last one here is the magenta variables. So they're all detagged there. It was necessary to redefine the word because these are macros. These call the macro dictionary, and jump won't jump to macros. It needs to jump to a word defined in the fourth dictionary. And that's how I redefine those words. Okay, getting back to... Oh, no, yeah, I don't want to shut down yet. In a minute. Media, Windows. Okay. 820. Edit. Alright. So here we are, 822. Now, here's some tricky code, right? We detag what we fetch. And I'm telling you right now that what we're fetching is this word sum. We'll detag the red word, and then we'll stutter. And stutter is to this will be show text, unpack, test, and repeat. Yeah, unpack any middle letter, and if what we've got left on the unpack will leave something. If it leaves a 0, then we'll skip over this. This if will allow us to skip over to drop it. But if it leaves anything else but a 0, then we want to repeat stutter, and we want to go back. And so this is one of the very special things that the return semicolon can do. It can take the word that it is currently defining and return to its definition address in dictionary and create recursion without loading the return stack with a whole lot of stuff. And then we can drop out of it and dump any artifact that's left. Again, now here I have a word to display the displays in different ways. For instance, there is a display with 0 and 5 is 5, but I can also show it in hexadecimal if I want to. Let's see, 824. Oh, I did it without setting. So let me clear that. 824, 800. I hope you've noticed that I've failed my way through every presentation so far in these movies. I've made mistakes all the way through the way, and so far the program has been very forgiving. It's returned immediately whenever I've asked it to, even though it's been offended with some of the things that I've done. But it's still pretty forgiving. I'm going to turn this on and reduce